Hello again. I'm glad to see any one of you today in our event. First of all, let me introduce myself. I'm Igor Borodowski, Sales and Support Engineer of Woodwork for Inventor team. Today we will speak about Woodwork for Inventor version 8. But first of all, let us speak a little bit about the general trends in the furniture manufacturing. Nowadays, customers are looking for the furniture which looks and functions great. And on the other side, furniture designers are looking for the software which allows them to make such a furniture. So we hope that with Woodwork we are right in the right spot and we have some tools to fulfill the needs of the designers. So let's start from the concept, how Woodwork for Inventor works, what makes it unique in between the other software that is in the market, and so on. So to understand the nuances of the software, we need to clearly understand the general idea. In the nowadays market, there is a general trend that furniture becomes more and more complicated. No one is interested in the box-like furniture. Everyone wants to get something unique. So on the other hand, furniture designers are forced to make those unique things. In case if we are speaking about this situation, designers are forced to make like almost new design each of the time. There is not such a situation when you do like thousands of identical objects if you are not serial production company. The general trend is just to switch to the more unique stuff, and it dictates the strategy that each furniture is a little bit different from the previous one. So that's why we have such a combination of two software packages. Like base for our add-on, we choose Autodesk Inventor, which allows you to model the furniture of any complexity and shape. But because primarily Inventor is a mechanical design software, there is something that is lacking in Inventor. So using Woodwork, we can assign woodworking attributes, make calculations, and prepare documentation for the manufacturing. So this is like a general idea. Inventor allows you to do complex things, but it doesn't know about the woodworking, and Woodwork makes it very powerful. So like a simple illustration of that process, we can say that Inventor is like an engine and the Woodwork is a performance tuning for this engine. That can be like an explanation. Often I get a question from the customers what we can do and why we choose Autodesk Inventor. Is it possible to do this or that? And they provide some examples that they made in AutoCAD, and they're asking about if this software is capable of doing this or no. Most likely that in most of the cases you will say yes. In this case, I get such a picture to answer to this question. So in simple words, if we can do this, most likely that we can do that. So it means that in terms of the complexity of the furniture, we are almost unlimited. So if it can be produced, machining production lines, we can design it in Woodwork for Inventor. Before we will dig into details, I'd like to speak about the general workflow that we have using Woodwork for Inventor software. So everything starts from a skeleton. What this one means? It's like very simplified model of your future furniture. As you can see, it looks very basic. So here we can have like multiple solids. Those can be like panels of your furniture. Also, some of those can be like the prototypes for the next steps. For instance, here I have like a block for the drawer as well as the block for the door, and later on the next step we will use such a functionality, which is by the way the new feature of Woodwork for Inventor version 8, which is called iBox. What this one means? It allows you to place predefined library components to some special places. So here, as you can see in yellow, there is the solid bodies, which marks that this place is intended to be used to place like a drawer or the door component. And after all, when we place a box, it's enough to only point on the right geometry objects on the surfaces, and all the rest is done automatically. We will see how it works more in details. The demo. Right now, let's move to the next point, and it's about the materials. Once we've dealt with the modeling in the skeleton level, once we put the iBoxes in the final assembly, when we multiply the identical items in assembly level, it's time to assign some materials. So we can assign the materials, we can set the grain direction as well as the oversize regarding the technological nuances that we need to consider during the production. Okay, once we have the material, it's time to place some hardware. So Woodwork is shipped with the hardware library, which is quite intelligent. It allows you to be placed automatically, and what is more important, it also allows you to drill holes. Those holes are mutually coincide in both connected items, so it means that there is no worries about if those holes are on the right spot or not. It's just enough to place right hardware item in the right place. Once all those operations is complete, we are finishing with the modeling and we are going to the data preparation for manufacturing. And one of the first step is the bill of material, or specification in other words. And as you can see on the picture, there is a fraction of the specification, and those of you who was already familiar with the 7th version of Woodwork immediately notice that there is something new. We have an images of the product like preview on our thumbnails in the bill of material, which is very nice to see how this part looks like. Okay, when we get a bill of materials, it's time to make some drawings, because in most of the cases the drawing is also a key for success of the data preparation, so you need to have some paper documentation. We are able to generate drawings automatically in the Woodwork. Once we're done with the drawings, it's time to make some CNC programs. Usually when we go to the client, we face with the situation when those CNC programs is made like in semi-manual way, using the part drawings. They import the part drawings in DXF format or something similar, and they apply technologies in a semi-manual way, which is like a time routine. It's not like a good way. Woodwork, on the other hand, allows you to automate this process and make this routine process very easy. And finally, once we have all the CNC programs, that is the time for doing the preliminary nesting, as you can see on the last picture. And there is also a new feature of Woodwork for Inventor version 8. So as you can see, you can place the parts on the workpiece in various ways. So it's very nice. Because you are allowed to reduce the waste of the material by simply regrouping parts in a visual way, just a matter of minutes, not the hours when you go back and forth between the workshop and the design department. So sometimes it also happens. Okay, now it's time to dig into details, and we will start from a design step. Okay, so design is quite simple on one hand, but it's quite complex on the other. So we are using a skeleton design approach. What this one mean? That we start everything from a general shape, so which in this case looks like that. Then we apply a skeleton option on it. We cover the surfaces with the panels. We can also clone the panels, trim the panels, or miter the panels. So we can connect them in like half of the angle, the angular connection. This is like also a new feature of the Woodwork for Inventor version 8. So final result looks like that. As you can see, it seems to be very simple, and in fact it is. And now it's time to prove my words, and we are going to the first video in our demo to see how does it happens. So what the skeleton design allows you to do, it allows you to create a parametric shape, parametric general shape of your furniture, which in this case would be like a regular box with the parameters which defines the width, the depth, and the height of the box, like a variables. So if we want to get some more parameters, it's also easy to do this. We can go to the functions, add the new parameters, assign the values. As you can see, we can use equation. There is no need to use calculator, because Inventor can do it for you. So it's enough to just define what is the thickness of the panels, how much drawers you want to have, how much shelves do you want to have in your design, and in this way you get all the controls in one single file. So if there is the need in the future to change something, it's enough to go to the parameter list and do the changes. So also you can set the parameter relations. You can say that one parameter is equal to the other, and so on. So now when the box is complete, you can pick the surfaces which would be covered by the panels, set the thickness from the parameter list that we defined in the previous step. Okay, and finally we just hide the skeleton because it's not necessary right now, and it's time to make a clone of the panels because we want to have some separators in between our sides. So we put one separator, the other one, and as you can see, there is the problem because those panels are intersecting. Now it's time to do something with them, and we are using trim command. So we can just select the panels that need to be trimmed, and if there is nothing selected all around, it will be trimmed by the rest of the panels, which is also the new feature of Woodwork version 8. So now we're using a miter, which allows you to get like angular connections. As you can see, it's enough to just pick two panels, and it makes the angular connection in between them. You can also mix the design approach that we suggest with the regular design workflow in Autodesk Inventor software. So in this case, I'm using a direct modification tool, which allows you to directly pull and push the surfaces. So once it's done, we can go back to our conception make the box visible, project some more reference geometry, and it's time to make a door. So here we are making like very simplified door panel because it would be used for a reference for iBox. So in the final model we will get the door like a door with the glass. Yeah, so but here we are making like a generalized box looking door object. So we can define an offset if needed. Okay, so we are using some reference dimensions like to measure the height of the niche for drawers, because we already know how much drawers we have. So we can just draw one, do some constraints, then put the dimensions, and the height of the drawer will be equal, like take the general height and divide it by amount of the drawers. As simple as that. And all that happens on the sketch level. There is no need to do some calculations, just show what should be taken into the formula, and that's it. So after all, that's the result that we have in the previous step. As you can see, it's very simplified furniture model, which basically contains one unique items of each of the components. We will have 2 doors, we will have 3 drawers, we will have some shelves and so on, but on the skeleton it's enough to have only one instance of those, because multiplication of those will be made on the assembly. So you can multiply those items in the assembly level like you normally do with Inventor. Okay, so let's take a look at this picture that you saw before. We did the first step, we made a skeleton, we have a furniture concept with the parameter set. Also we made the panel bodies, and also we defined the place for iBoxes. So as you can see on the right picture with iBox, finally we will get the door with the glass, we will get the drawer as it should be with high detail level. So now let's go for the next question, iBox. So this is a new functionality of Woodwork for Inventor version 8, and what this one makes, it allows you to create such a intelligent standard object like drawers, like even cabinets, cabinet blocks, whatever else, the doors or something, which is like parametrically driven. It can also have some iLogic rules inside, and to place the iBox you basically need to show the place in which it should be placed, yeah, and also you need to pick some reference geometry like the front or the top or the side of the object, and it adjusts the size automatically. So it's always better to see rather to hear, and let's see how it happens. Now we are making a new assembly file, so now we are on assembly level, and we are going for insert command. First of all, I made some panels invisible, yeah, and this is like a new iBox insert command. How does it work? You pick iBox component, and basically you need to pick some reference geometry. So once again, we pick the door facade, and now we need to, the drawer facade, we need to pick the reference surfaces, and that's it. The drawer facade is on the place. So once again, the same with the door. We are picking the solid, we are picking the part, and we're picking the surfaces on that part, and the door automatically jumps to the place. As I said, those can be equipped with the logic rules. In this case, I can switch the hinge position from left to right, and as you can see, in just a few moments we get the final situation. So once we placed iBoxes, we can multiply the items in assembly level like we usually do with Inventor. You can use patterns, you can use mirror function, whatever else, and as the final result what we get is like the model with right structure that should be presented. So now we're mirroring the door from left to right because it will be a symmetric object. We are just using a reuse option instead of making a new parts. Also on this level we can do some restructurization. So if you'd like to make a frame like a separate sub-assembly, it's up to you. You are free to do this. Just regroup the items, make them grounded, and you can also use a mirror again to mirror a frame sub-assembly from front to the back. Also we reuse it because in fact it's the same. And as you can see, in very short time we get the final result. So Of course, this video was sped up a little. I believe it's like between 20 or 30%, but it's not a drastic, speed up. You can imagine how long does it take. It's not that much. So if you compare this with the traditional design approaches, you will see that this is like a huge benefit. Also, you need to keep in mind that this method allows you to design various shapes of the furniture. It's not limited by the boxes. I choose this simple shape to make my explanation clear, but you need to always focus your attention on that you can design virtually everything that can be made using mass production tools. Okay, so we made a conception. Let's see what we get here. So we place iBoxes, we duplicate instances of an object like shelves, drawers, frame, and so on. So we get like a complete assembly part set. Yeah? So we get all the parts within our assembly. Now it's time to apply some materials, because we just place the objects, but there is no materials on them. So let's see what we can do with the materials. So there is a lot of the things that Woodwork can do with the materials, and one of those is like we treat the materials in the way that Woodworker do. Each part is treated like to be a small assembly. Let's see what I have in mind. So there is like two main materials. It's like fill material and the cover. So speaking about fill materials, those can be like a solid wood part, boards, laminated boards, multi-layer boards, desktops, profiles, and that's the main fill materials. So of course in between the main groups there is a bunch of other materials. So for instance, in the laminated boards you'll get laminated boards for the facades, for the bodies, and whatever else. So some of the fill materials like boards can be also covered by the cover material, which can be laminate or veneer, edge banding, or paint. So why you have such a lot of different kind of the materials? There is the simple answer, because each of those have his own way of to be produced. If you have a profile, it's enough to cut the exact length that we need. If you have a laminated board, we need to be precise in cutting the right area. It's important how much square meters we will have. If you are speaking about the solid wood parts, then the volume becomes important. So we need to know how much cubic meters we will need to request from our supplier to make such a furniture. Moreover, each of those have his own unique features. I will not speak about all of them, because like it will turn to the training session, not to the presentation. But let's speak about the multi-layer board, for instance. So this is like some artificial material. It's not like a real wood from the tree. It's made by engineers. So in some of the cases you need to use it to make your panels visually thick, but at the same time quite light. So you can use such a multi-layer boards which have multiple layers of the core material as well as multiple layers of the covers. Yeah. So what is important that in Woodwork you can design it to be like one single part. So in design you just care about the total final thickness, but inside of the description of this material you can define what is the properties of each of the layers, and you will get precise calculation on the bill of material. Also, if you're speaking about the covers, there is a lot of nuances that we consider in Woodwork system. So first of all, we consider the cover position, because let's imagine the situation that we model a workpiece and then we assigning some cover on the top of it. For instance, let's imagine that we have a top view of the panel and this is edge banding. So the final part dimension will be different, and it's also automatically calculated. So the opposite situation can be if we have a model in a final condition, but we want to calculate the size of the workpiece. So we are saying that this is like a final part, so please calculate the size of the workpiece for it. If we apply, let's say, 2 millimeters of the edge banding on top of it, it automatically calculates the size of the workpiece according to the edge banding. Also, you can adjust the oversizes for the technological purposes. You can change the grain direction, which also affects the workpiece size, and all of that is made automatically. So for you it's important to make model correctly. If the model is designed correctly in Woodwork for Inventor, so all the information will be adjusted automatically in the right way. Okay, so now let's speak a little bit more about the material assignment, and we will start from the conception. So we suggest to split material assignment into stages: on the design stage as well as the bill of material calculation stage. So on the design we can assign generalized materials like corpus materials and facade materials, for instance, as you can see on this picture. So we don't know yet what material exactly will be used for the body panels as well as for the facade. It's unknown at this moment. We can use similar approach for the edge banding. So we can say that those are like for the body panels, and those are for a facade panels. So what we get as the result? As the result, we're getting some generalized materials, as you can see on the left. And Woodwork is equipped with the tool which is like a replacement configuration. What it allows you to do, it allows you to change this generalized material into some real one. And you can do this very easily on the bill of material level. There is no need to change something on the model. So you can have as many configuration of material replacement as you want. So you can say your corpuses was made from the walnut, birch, oak, whatever else, by simply choosing appropriate material in the BOM. So what we have in Inventor difference from what we see in Woodwork for Inventor, because parts in Autodesk Inventor is like one single item, which is in fact not true in terms of the how woodworkers sees them, because for the woodworkers it have like multiple layers, like fill material or core material, cover on the top, cover on the bottom, edge bandings all around, and so on. So all those small nuances is interpreted by Woodwork for Inventor. Moreover, each of those layers can have some technological oversize or other nuances according to the grain direction, according to the oversize made manually, according to the edge banding position and thickness, and so on. All those nuances are considered during the calculation. So once again, for you it's important to make your model in the right way, and you will get right calculations. So now let's see how it happens in real life. Some iBoxes that I placed already had a material. That's why I don't need to assign the material twice. But now I'm on a multi-layer board, and because we have quite thick panels all around the model, I'm assigning a multi-layer board to get this thickness. Yeah? And in a multi-layer board structure, I get all the layers predefined. So there is no need to define them like a separate layers. Okay. Now I'm assigning a rod material, which is like a profile for the frame. Okay. Now we are going to the boards. I assign the board type of the material for the glass because it's measured in square meters. Okay. So now we are changing the visibility. We make some components invisible, and it's time to assign some laminated boards for the parts which had no material in the moment. And as simple as just to click apply button, because we can assign materials to all let's say empty parts in one simple command. Yeah, just assign material to the, let's say, empty parts, the parts without materials, and that's it. So now we are assigning the edge banding. Again, with the edge banding we can say what is the thickness of the edge banding, and as well what is the position. It can go outside of the model that we have, and also can go can be oriented inwards. Okay, once it's done, we are going back to the top level of our assembly, because we need to apply edge banding all around the perimeter. So we're choosing the surfaces that need to be covered with the edge banding. We're just saying apply, and that's it. So we have basic materials assigned. It's time to set up the grain direction. So I want to change the grain direction on the facade. Yeah. So that's the new grain direction, as simple as that. And also we can assign some technological oversizes. For instance, I'd like to cut the glass in a little bit oversized way before the production, so we can just simply set the oversize for the panel in such an easy way. So as you can see, it's very easy to assign the materials, and all those materials includes technological nuances, which is important for the woodworkers. So after this stage, what do we have? We have assigned woodworkers materials and covers. We set the grain direction. By default, the grain direction is set to be in parallel with the longest edge of your part, but if needed you can change it. You can set it to be parallel with another edge. It can be rotated by some angle, and so on. Also, we define the oversize for some of the parts. So basically that's all the stuff that we have for now. And now we are going for the hardware, so for the things which joins panels together. And what is important, that the hardware also brings right holes to the model, to all the joint items. So speaking about the woodwork, once again, it is shipped with a hardware library, which is unified for any manufacturer In a moment I will explain what I have in mind. It is driven by Microsoft Excel spreadsheet. In fact, it utilizes iPart functionality of Inventor, which means that you can have one single item with a huge parameter list in a spreadsheet. It's enough to just choose the right configuration that you need to use in this exact case. Okay, and the parameters will change the model. Okay, so it is automatically placed. You need to just pick some reference geometry and all the hardware items will be placed on the right position. And as already said, hardware also brings holes. It means that if you have two or more items joined together with the hardware, it's enough to just adjust the hardware item in the right way and you will get right holes or even joints. So let's go back to the question about the unified hardware library, what this one means. As you can see on the left, there is some door handles which can be made from metal, glass and so on, from other materials. They can have also a different engineering nuances, but what they have in common, they have the same drilling scheme. Yeah, they have same distance between the holes. So in Woodwork we can replace all those handles with a single one, but which one to take? Which one of those three will be requested from a supplier? When we have the holes on the right position, it's important to know which one to request from a supplier, and the answer to this question is we can use bill of material code. Yeah? So if you have a holes on the right spot and if you have the right code for the components, we can be sure that everything will go smoothly in the manufacturing process. So let's see how this happens. Let's go back to our assembly. We can change the visibility of some of the components to leave only the body. Okay, and now we need to generate some reference geometry, which would be work planes. As you can see, once I made 4 work planes, we can go back to our assembly and just add some more work planes on the shelves. It's nothing more than usual using standard Inventor functionality, which allows you to make work planes like reference geometry. And once it's done, we can go back to the assembly level, go to Woodwork Design, Attach, to place some component. So this Attach command allows you to place components from the library. You can choose the configuration that is suitable for you. And basically now what you need to do is choose a reference geometry, which would be a nested board, the pillar board, and where would be an axis. And basically that's it. So it's very easy to understand how it works. Just a matter of half an hour of practice and you are feeling like the fish in the water with that command. So we can repeat this command as many times as we need to place various hardware items. So in this case I'm placing a minifixes. Okay, we can also use some geometry from an origin for a center planes and so on. So as you can see, in just quite short time I already got all the geometry on the right place. So we can change the visibility of the components to hide all the panels, and now we clearly see only the hardware items. We can change the configuration of one of those, and this one can be used as a template to change the others. Yeah, so we pick this item, and now we need to click on the items which configuration should be matched with the first one. So we are matching the configuration of the selected item with the configuration of the template. As you can see, it's easier to do rather to explain because it's very obvious. We are just choosing the item and clicking on the configuration and clicking on the other one, and their configuration is identical. Becomes identical. Okay, once this primarily configuration is complete, we can attach some more components, for instance the holders for the shells, which can be also configured to change the amount of the drillings on the sides. And basically the idea is the same. You need to pick the reference geometry, pick the bottom of the shells and the axis. Okay, and that's it. So we have the supports on the right spot. Okay, so now we can do something more. We can place a logic component. What makes it different? It has some embedded logic inside. Yeah, so we can change the configuration of the item, place it on the side, and again we can use the same principle as we already saw. But first, let's make this component adaptive. Who uses Inventor knows what I'm speaking about, because the angle between the panels can be different. We have an angular joint, so we need to make it flexible. We need to make it adaptive, sorry. And once the component is adaptive, it can change the angle, so it adapts to the situation on your assembly. Because you can basically have not like an angle equal to the 90 degrees, but some other angles. So once we done it, we just remove first reference object, and that's it. So basically we have the hardware set on the right position. With one exception, there is some more hardware left for the frame. It will be joined with the conformat, so we can pick the configuration. Once again, each single component is like representing hundreds of possible combinations, because it can have like Excel configuration list, so it's up to you to choose the right one. Of course, if needed, you can easily create your own items or change existing by simply opening the Excel which drives this component and entering the parameters that is necessary for you. Okay, so we get all the components on the place, and the last step that we need to do is apply sculpt command, which basically generates all the subtraction to remove the geometry on the right place, like for the handles, for hinges, for minifixes, conformats, shelf holders, and other stuff. So once again, if you place the right hardware on the right spot, you can be guaranteed that your holes will be on the right position with the right configuration. Moreover, Woodwork allows you to work with a solid wood joints, so which is like carpentry art in the general meaning. So it means that it operates with Excel-driven components, which allows to add material to one of the items and remove the material from the opposite, from the other one. Those of you who are working with solid wood things can be happy with that tool. That's why it's called like a sculpt, not like a hole or something, because it allows you to work like a sculptor, to remove the material on the one place and add it to another one. Okay, so once we place the hardware, we get it on the right place automatically. It's easy to configure, to change the configuration of the hardware, and we get holes in the right place. So now let's move to the bill of materials. Okay, and usually we face with the situation when the bill of material is managed in a semi-manual way. When there is the person in the company who is like a full part job to generate the bill of material list. He or she analyzes the model and just make the calculations with the calculator and so on. It looks very weird and it takes a lot of time. So we solve the situation in a very elegant way. So speaking about the bill of materials, it's model based. It means that what you made in your model, you will get exactly the same in the specification. We calculate cut parts, including the grain direction, effect, the edge banding, thickness and position, and so on. We calculate the dimensions and the quantities of the material. We differentiate what is the purchase or hardware items. We put order information. We get information for the prime cost estimation. So basically the bill of material of Woodwork for Inventor can look like that. Why it can look like that? Because it's like template driven thing. It means that different companies have their own vision of how the specification should look like, and it's a matter of the template that you are using. You can choose one template to get the same data shown in that way that you see on the screen, and you can filter this data through the other template to get them shown in the other way. For instance, for the ERP system, it's the matter of the template that you are using. So speaking about the templates, there is no need to be a programmer or very high skilled persons to do some adjustments. It's enough to open an Excel file and change the ordering of the keywords or add your own keywords from the list that we provide to get the data that you want in the place that is necessary for you. So let's see how it happens. When we have a model already made, it's enough to just click on the Bill of Material button. And as you remember, at the previous step we worked with the generalized materials that I showed you. It's like the facade and the body. It's time to assign the real materials. And it can be done using Excel as the source of the data. This Excel can be like a snapshot of your ERP system. So you can ask the ERP guys to show the export, to make an export of the materials, and then you can adjust those from the Excel. You can set different materials for different thicknesses if needed. For instance, if you have a glass, there is like 5 or 10 millimeter glass, you can assign different materials from the list, because they can have different prime cost depending on the thickness. So the thicker glass usually costs more than the thinner one, with some exceptions, of course, as usually. So basically the general idea that you can have a complete list of the materials in Excel. There is no need to do changes on the model again and again, jump back and forth. It's can be done very easily. Moreover, you can also have some predefined replacement configuration to use them in the future. Now once it's done, it's enough to just choose the template file, which works like a filter, which is in between the final output and all the data that we can calculate, which shapes the data in the right form. And once it's done, you can also open final result. As you can see, here we have a nice looking product structure with the thumbnails, with the small pictures, which indicates you how this part looks like, as well as the material thumbnails, which shows you how this material looks like. It's very nice to see it on the list. And with the vanilla inventory, you are not allowed to see such things in the bill of material. So once you configure the template, usually there is no need to do some adjustments. You can just say, okay, generate the bill of material, and that's it. You are always sure that it will be precise. So from a designer, there is like only one requirement: to not make mistakes in the model. So as you can see, there is various ways of showing information: the cutted part, the total part list, the summary of the objects, and so on. So we can use the same model but with the other template to get the prime cost calculation. We are saying that this is a new file, like a price calculation list. Okay, and now we are generating the Excel again, and what you see here is like the Excel which looks in the other way that we saw before. In the material summary, there is only 2 pages. One of those is like material summary, which contains the prime cost for your items, so which is very useful. You can get like a prime cost by simply using a price list on your company. So it's like the matter of playing with the templates and adjusting them in the way that is more suitable for the need of your client. Okay, so once we have so far is template driven bill of material. It's model based and shows you the size of the part as well as the workpieces according the grain direction, according the edge banding position and thickness, and technological oversizes. If you have like a multi-layer boards, those are like in exploited view. You see each layer separately. So now it's time to go for the drawings, which, as you know, one replaces 1,000 words. So let's see what we get in the drawing. The drawings is also template driven, so which means that the way how the drawing looks like can be easily adjusted by simply changing the template. It shows you the grain direction or the texture direction. It shows you where is the edge banding. It shows you the codes of the material as well as the name of the material on the title block. You see the general dimension. You see the drilling table. You will get the coordinates of the drilling and all the information that you need. For the production, if you made a CNC, you will get the base point shown on the drawing. The position of the drawing can be synchronized with the bill of material, as you can see here. So the items on the BOM matching the items on the drawings, which is very nice in my opinion, which helps you a lot to get the best results possible. Also, some cases there is a need to show the parent assembly information on the drawing, because if you get the drawing of the part, you don't know to which assembly it belongs. So Woodwork can show you the parent assembly name on the drawing. Parent assembly name on the drawing is very useful in some of the cases. It helps you to navigate in the printed drawings in a very easy way. let's see how it happens. Now we have an assembly. We are going to the auto plot, and we can just briefly go through the template to see what you can change. For different in different aspects of the drawing, you can change different things. For instance, the projections, the output area size, what is the colors for the lines, what is the thickness of the lines, do you want to get a whole table, whole chart or not, do you want to get some whole indicators, in what way they should be assigned, the tolerances, the coordinates of the holes. Do you want to get multiple files, or you want to get individual file for each of the drawings? And a lot of additional things can be adjusted on the template. Of course, usually it's done only once, because all the rest time you can use predefined templates again and again. And basically that's it. So when we define a template, you can use it again and again in the future to produce the drawing. So from the user perspective, it's enough to just click on the bottom, and everything that is in the model will be represented on the drawing pages. So as you can see, each of the part is oriented in that way that as many holes as possible is on the top. We get the coordinates for the holes, we get the whole chart on the top on the drawing, but it's like the matter of adjustments. If you like, you can change the position, move it to another side, and so on. We get the grain direction, we get the edge banding, the color represents different thicknesses, and in this way the template shows the main assembly, and then it goes through the subcomponents, and then it repeats this again and again till it gets the reach of the assembly. And as you can see, it saves a significant amount of time on the drawing preparation. You can imagine, like only one example, you can imagine how long it will take just to place the drawing in a manual way. You need to rotate each of the part in the way that as many holes is on the top. So you can imagine that it will take like a half an hour, maybe more, only on that. I'm not speaking about the indicators of the edge banding, about the grain direction, whatever else. So it's like a huge time saver for the designers. So in terms of the drawings, they are template driven and model based as the bill of material. You will get basically all the information you need for the production of the drawing automatically. So you get the grain direction, you get the holes annotation, you get the part and workpiece sizes, hole coordinates, and so on. So now it's time for speaking about the CNC. It's like a computer numeric control. So there is no room for mistakes, because the further you go in the design, the more expensive mistakes became. So if you made a mistake in the design, it costs you like 1 minute to change something, but if it is already shipped with the car to the client's site, it's very hard to do some changes on that level. You need to just ask the guys to bring the things back together on the workshop and do the changes. So there is no room for mistakes, in other words. Let's see how we can deal with the CNC, one of the last steps on the preparation for manufacturing. So there is two ways of making things in woodwork. If there is like quite complex geometry, or there is some technological nuances you need to consider, you can use manual CNC program generation, which means that you can basically generate a job setup, you can set the clamping, you can make an operations and output the CNC program in a manual way. So now we will speak about each of those steps in more details, and we will begin from a job setup. What this one means that we need to define how our machine is equipped with the tools. So what tools are presented in our machines, and we call it like a tool pool or tool database, which shows you geometrical parameters of your tools like working length, diameter, and so on and so forth. And once we defined all the tools, we need to place them into the spindles, because spindle defines how this tool can be rotated, in what angles, in what direction, what is the feed rate, what is the rotation speed, and so on. So by combining all those nuances, we can define how our machine behaves. So what is the machine behavior options, yeah? So how we can utilize all this equipment. And finally, we assign all that stuff into the real machine, like the router on the woodwork matches real router which is on the workshop. So now let's speak about more those technological nuances, and we will start from the clamping. we can clamp the object in two conditions. It can be a workpiece or it can be a final part. And of course the size of those is different. And when we defined that, we can choose the base point. Yeah, because the base point matters. If you want to get highest precision, we need to try to put as many holes as near as the 000 coordinate of the CNC machine to avoid this tolerance flaw. Okay, and there is 5 main operations that we can do with Woodwork. It's like drilling, milling, pocketing, growing, and the cutting. And finally, we can output the CNC program to different CNC machines. So you need to have in mind that Woodwork automatically prepares the technologies for the parts, but now we need to tell the system in which machine we want to pass those technologies, because different CNC machines, let's say, speaks different languages. So one of those speaks German, another Italian, and so on. Let's simplify it to that, simplify this explanation to that level. Then we need to have a translator between the Woodwork technologies and the real CNC machine. So we have a post processors in between. Okay, so in this case it works like a translator. And we are always asked by the clients what the post processors we have in our system. So here you can see the list of the post processors that is currently embedded into the system. I will not read them loud because you read faster than I speak. Yeah, you already read the things. And the main idea here that basically we can provide information to the very many machines. More post processors is in the development at the current moment, and moreover we can even make a custom post processors on the client's demand. But it's the matter on the other topic. But in general, even the custom post processors can be made. Okay, now let's see how it happens in the real case. Just to illustrate the difference between the part and the workpiece, we will take one of the parts and we will quickly assign some oversize to it. Just a little oversize, like a few millimeters. Let's say that just to calibrate the part, to remove some excessive material, damaged edges, which can be like an often situation when the part lies on the floor and so on the workshop. Sometimes it happens, so we are flipping the part in the right way for us. We are choosing the router, which would be a Woodwork in this case, quite common machine in Europe, and Woodwork is like a front-end application for the machine. So we are choosing what is the condition. Is it a workpiece or is like a final part, and according that the clamping position changes. So now we are doing technological operation, and you saw in green that there is like drillings available to do with current setup, including the tool set according the spindle setup and the machine setup that we had. So we made those operations. Now we are going back to the assembly, and as you can see, this green indicator showed that one part have the technology already made. But with Woodwork we can do the technologies for all the assembly automatically using some rules. So there is like a lot of rules which defines how the machine behaves. For instance, what is the priority of the operations. For instance, let's do a cutting, then do the milling, or vice versa. Also in one of the operation we can also define a priority. For instance, try to make a hole using drill tool or try to mill the hole. Okay, and as the result what we get is like a list of programs, which is in fact MPR programs because I used Woodwork like the output. Okay, and as you can see we have like a set of the programs. It's just a bunch of the files which we get automatically, and in this case in Woodwork we have a grain direction indicator, we have the edge banding legend, we have the material like a comment in the program. So for the CNC operator it's very beneficial things, because on the screen of his CNC machine he sees what is actual parts he's processing. There is no need to look to the drawing and go back and forth between the drawing and the screen on the CNC machine. All that is generated automatically, which is very nice. Okay, so just a brief conclusion on the CNC. We get rules-driven CNC machines. We have all the tools loaded into the spindles and so on. So we have like a digital prototype of the CNC machine inside of the Woodwork, and Woodwork knows what is the capabilities of your CNC machines. The recognition of the technological operations is geometry-based. So what this one means that basically it's not important how you made your geometry. You can, okay, let's speak about holes, for instance. You can use hole tool of Inventor, you can use cylindrical extrusion, you can use hardware of Woodwork for Inventor, which is of course the best solution possible, and in any way it will understand that this is like a drilling. There is no strict workflows, you can only do it in that way, not in the other. No, you can do designs in the way that is more suitable for you. You don't need to care about the system, because the system is quite intelligent. Woodwork understands how those geometrical objects should be processed. And we get a bunch of post-processor inside of Woodwork, and we can provide CNC programs to multiple machines around the world. And what we get as the result is like ready-to-use programs. We can just pass this program to the machine using network or some other way, and you will get this done. Okay, now let's move to the nesting, because all the time, especially in the mass production, you want to optimize the material waste, how much material you waste on the production. So in Woodwork 8 we have like a preliminary nesting. So what this one means, it's like the nesting which allows you to do some adjustments. It's not provide like the final result, but it shows you like preliminary adjustments of the parts on the worksheet, and you are ready to do some tweaks if needed. All those parts are shown in different pages, which represents different materials. As you can see, they have unique numbers, so you know which one is which one. And to change the position of the component is simple as like pulling the components from the sides, from left to the right and so on. It's like a virtual to call it correctly, like the desktop. Yeah, so when we're done the adjustments, we can crop the sheet. As you can see now, we are ready to go for the output. We can just generate the XF file in some of the folders, and it's up to you how to process this part. You can send it to the nesting machine, which can read this data, or you can open it in AutoCAD to do some fine-tuning if needed, and so on. So it's up to you. In this case, as you can see, we'll get a bunch of DXF files, which each of those represents different sheet on the nesting, different worksheets from different materials. Yeah, so you'll get all the things in one defined folder, which is very nice. So after the nesting, what we have, it's like automatically done. We have different materials in different workpieces. You can override the default layout, you can change the object position, and finally you can generate a DXF output. Okay, now let's speak a little bit about the model itself. It's parametrically driven. It means that if you need to do changes, it's quite easy to do this, because you can always go back to the parameters. In this case, we are going back to the skeleton file, and it's basically enough to go to the functions, and in case if I need to change the width, the depth, the height, or the drawer quantities, as easy to do as changing the parameters. Okay, so for instance, we change the geometrical properties of our model. Let's make it a little bit taller and make the 4 drawers instead of 3, and 3 shelves instead of 2. And when we go back to the assembly, it's enough to just refresh our assembly, and that's it. So we basically get a new design in the matter of seconds. So you can imagine how easy it is to do changes, and because of a lot of the automation, it's enough to just regenerate the information that was already made in the previous step, and you will get new bill of material, new drawings, new CNC programs, and the new nesting file. Now let's speak a little bit about the collaborative environment. It's not the feature of Woodwork for Inventor, but we can provide the data for Autodesk Vault PDM system in the way that is understandable for the Vault to increase the productivity of the clients. So just a few words about the Autodesk Vault. What it basically is, it's like collaborative environment which supports any CAD system. You can import and export CAD files in different formats, which actually happens probably on most of the client side. We get AutoCAD drawings somewhere in different ways and so on. So you can just group the things in one central location. You can easily find the data that you need. You can reuse it. You can do a concurrent design, so multiple users can work on the same thing. And you'll get automated tasks. And you'll get revision control, BOM management. You'll get automated engineering, change to order, ACO. And also you'll get ERP integration. So basically it's like all the basic stuff from the Vault. Of course, it's not the explanation about how the Autodesk Vault works, but it's like the key points. So what Woodwork can do with the Vault, it can basically generate an item structure within the Vault. So what does it mean? You already saw the explanation that each part in Woodwork is like a small assembly from multiple layers, like core layer, covers and so on. And we can basically commit the items from the Woodwork for Inventor inside of the Vault. You can just do a transfer of the items. So how it happens in the real case, again, just a short video to show you. So we will have a model right now, and we are going for the bill of materials, and it's calculated automatically. So we are going to the settings. We can define the units. We can define the properties that we want to pass from Woodwork for Inventor inside of the Vault. It's highly customizable, so you can define virtually any property that is processed by Woodwork and send it to the Vault. Okay, and in the item master, which is basically a prerogative of Vault Professional, you can see all that stuff. So each workpiece, each cover material and so on will be shown within the Vault. You can categorize them by different criteria, like the category, for instance, and you can expand some things, like now we categorize them by type, so we can expand the items by type and see them in a single list or in the individual list. So if you collect some item, you can see that there is also additional information connected with this item. Like if you have a part, we get the CNC program for that part. We will get the drawing for this part. If we have an assembly, we will get the bill of material for this assembly automatically generated. So the structure of each part of the Woodwork for Inventor is shown inside of the Vault. We'll get the size of the workpiece, we'll get the size of the final part within the Vault, which is very, very nice. Okay. We know where the things are included, in which assembly we'll have this part and so on. We'll get all the properties. We can do some real-time adjustments if we need to have some more properties like length, width, depth, or something more geometrical information. We can easily do some adjustments. We can change the order of those, and as the final result we get the length, width and the thickness in the browser of the Vault, so which is like very nice to have. Okay, now let's speak a little bit more about what's new is in the 8th version of Woodwork for Inventor. Just a conclusion of the new features, because they was like spread it all around the demo, and it's quite hard to catch all of them. Maybe some of those was not even shown because it's like time limitation. I know that I promised you to fit in 1 hour, but there is too much of things that I'd like to share with you, and we already spent 10 minutes more than it was planned, but I believe you will forgive me for that. So let's see briefly what we get new in the 8th version. We will start from the hull nodes on the 3D model. What this one means, it allows you to define the tolerances as well as the marking of the holes, and in the drawings you will get all that stuff. So each individual type of holes can have different marking, different tolerances, which is very useful in some of the cases. Our customers asked about that, so now this information can be shown on the model. Panel miter or meter join, which allows you to cut the panels in half by the half of the angle to get the metered trim. It was shown on the design, but maybe you didn't notice that. So preset material oversizes. Some of the material can have oversize which is predefined. For instance, if you're working with the veneer, usually the size of the veneer should be a bit bigger than the size of the panel. Yeah, so you can define in which direction in X, Y, Z. Yeah, so in both directions can be oversized by different values. Yeah. Also, you can define what CNC machines will be used for this material. Yeah, because in some of the cases, different materials can have different processing nuances. For instance, solid wood parts and the panel parts can have different tools on different machines. So we can define what machine is more prerogative in terms of the material. Yeah, so each material can be processed on different CNC machines. In some of the cases, there is the need to change the material in a model. For instance, if you import this assembly from one PC to the other and it does not have this material on the database, or you suddenly decide to change like white facades to the black, you change your mind. Yeah, so there is a tool which allows you to see a list of used materials, and you can just say, okay, I want to change this to that. As simple as that. Just change the one material to that. Okay, so improved material and color replacement in the bill of materials. Now we can assign different Excel document to different kind of the materials. So solid wood can be replaced from one Excel and board can be replaced from the other one. Also, you can define different spreadsheets in Excel. So for instance, you can define them by the material type. Let's say laminated board is taken from the same Excel but from the other tab, from the other spreadsheet. Okay. And iBox, you already saw that, but it was like quite short in the total demo. So the idea is that initially you can define the concept of your design, like it can be like, for instance, the kitchen. Yeah, so you can have a kitchen layout where each of the cabinets is shown in a very simple way, like a box, and then you can use iBox tool to fit those boxes with the real cabinets. And when you show which box will be used to place this cabinet within, it automatically reads the size of the box and adjusts the size of the cabinet accordingly. Also, those iBoxes can be equipped with the logic rules, which makes them even more powerful because you get like very flexible controls, and it's like a huge time saver for those who's working with the cabinetry furniture, especially for the kitchen designers and so on. The holes in the drawings, as you already noticed, the holes on the drawings is shown in different ways, as it was in the 7th version, because now we provide a bunch of the information about the hole drillings exactly on the drawings. It's not only on the whole table, but it's on the drawing. It's like more user-friendly, I would say. Yeah? So for the people, it's more natural way of seeing things. Also, speaking about the whole table, now it's allowed to use templates to adjust the way how the whole table looks like. So the whole table becomes template driven. So we can adjust the way how the whole table looks like. Okay, so automated drawing refresh improvement. So first of all, our customer reported that the reliability of this refresh function is not very great, and we work hard on that to improve it. And now we hope that it's way better as it was before. So, but there is another thing that is very important for those who already have a legacy data, and we can enrich existing drawings with Woodwork for Inventor information. So if you already have a drawings made exclusively with Autodesk Inventor, you can ask a system to refresh them to add some features which is made by Woodwork for Inventor. For instance, if you set the materials, the grain directions, the edge bandings, and you want to see them in existing drawings, you can do this. Just set the styles and just go ahead. So the clamping, it's also improved, because in most of the cases you need to care about the precision how the CNC programs was made, and there is the attention that, so looking from the front, your furniture would look as much good as possible. So you need to keep all the tolerances according the base point on the front. So you can define where is the side of the final assembly which should be like the front, and Woodwork can automatically treat this as to be a front. Yeah. So moreover, in general, the clamping algorithm was improved. There is like a weight system, or like a priority system, which allows you to say that, for instance, keep the holes as near as possible to the zero coordinate of the CNC machine, or place like for instance pockets as near as possible to the zero coordinate of CNC machine, and so on. So you can just balance between those to find the right situation for you, because many of the companies, they focus on one kind of the furniture. They can just find let's say the balance, which adjustments is more suitable for them, and then they can use it in the future designs. Okay, the preliminary nesting, the nice feature, long waited for many of our customers. What it does, it allows you to place many parts inside of a workpiece, virtual table, and you can just drag them to find the right combination, how they should look like. It's like preliminary nesting, and then you can finally define the output file. Also, we improved our web. There is a new learning path, new support desk things, and of course the new help file. So we are improved all those things which makes the customer life easier and the user experience better, speaking about how you get the information. So if there is something that you don't understand how it works and so on, so you can go for the videos, which most of the cases is like the right place to start. Then if you don't find the answer, and if you want to get some more explanation of how the system works, there is the great manual which explains how the things work in details, why, and so on. And finally, if there is nothing that you'll get the answer from, you can address a question in our Fresh Desk system. Okay, and now let's speak about the time management. For many furniture designers, time management can be a major struggle, but it doesn't have to be. Okay, now let's see what is the typical designer's time management. And our many years practice shows that there is like a similar situation as you see on your screen. On the 3D design, designer sits about 40% of the time, and all the rest of the time is spent on the data preparation for manufacturing, which includes the drawings, the bill of materials, CNC programs, nesting, and whatever else, which is not very creative tasks, and it's like a routine, but it's necessary to be done because otherwise the furniture will be not produced. So everything changes when the woodwork arrives to the scene, because it drastically reduces those times. So speed up the 3D modeling, because you will get like a skeleton design approach, you'll get automated drillings for the hardware, you'll get a quick and easy way to adjust the materials, and you will get iBoxes, which allows you to place standard objects very easily. So it's reduced in some proportion, but it's drastically reduced the time for the preparation for the manufacturing, which is very important, because it's in most of the cases it's like a routine manual work, which is source of the mistakes and errors. Okay, and in most of the cases we allow to save like 50% of the time on that. Moreover, because of the higher automation, the chance to make a mistake is reduced by more than 80%, which is also a great thing. Now we can speak about the examples, because usually we get the questions, what kind of the furniture can be made with a Woodwork for Inventor. In fact, there is a lot of various furniture type that can be made. There is no restriction that you can face with, so virtually any type of the things made from the wood can be designed in Woodwork for Inventor. Just a few examples. As you can see, it can be like a solid wood cupboards, it can be like commercial oriented furniture, like hotel rooms, like some office desks, doors, windows, stairs, the bank, cabins, rooms, and so on. So it's completely up to the fantasy of the designer. So there is even a boat cabin concept, which is very interesting, because the shape of the boat is quite complicated, but we can use it as a reference to fit it with the furniture. So that was basically the explanation of the features of Woodwork for Inventor and the new features of the Woodwork for Inventor version 8. And I'd like to thank you very much for your time,